Thank you all for joining. Hello and welcome. Thank you for spending the time. My name is Mouaz Alnouri, and today I will be talking about the big data for cybersecurity. As I mentioned, this session will be recorded and will be posted on Skilledfield's YouTube channel. So to start by introducing myself, as I mentioned, my name is Mouaz Alnouri, and as Astrid mentioned, I am the Managing Director of Skilledfield. I am coming from a telecommunication background, and then I moved into the big data domain and then the cybersecurity domain. At the moment, I am a big fan of implementing cybersecurity solutions using big data technologies for telecommunication companies, among others. I am a big technology fan, and I am very blessed to be leading the Skilledfield. Here's the agenda for what we are going to cover today. I'm going to give you one slide, a quick introduction about Skilledfield in order to give you the background and the context of what we are talking about. Then I will be talking about why cybersecurity is a big data use case. Then I will be talking about how to address cybersecurity as a big data professionals, what are the advantages we have, how to implement our big data thinking into the cybersecurity world, and then how do we keep up with emerging cyber threats? How do we keep up? How do we utilize the latest technologies and the latest updates and the latest trends in the big data domain in the cybersecurity? And at the end, I will highlight what are the benefits of us as big data experts getting into the world of the cybersecurity and helping our folks in the cybersecurity domain. So Skilledfield, we are an IT consultancy and professional services company. We are a field full of skilled professionals. Our purpose is to solve complex problems with simplified solutions. And we focus on unleashing the power of big data technologies to resolve cybersecurity problems, among others. So we utilize big data technologies to uplift security detections and response capabilities for organizations. We utilize big data technologies to help organizations uplift the observability capability. And we utilize big data technologies to uplift the maturity of the analytics services for any organizations. We take the customers through the journey of the big data, starting from the design, develop, engineer, all the way until providing an insights using machine learning and artificial intelligence. For any more details, please feel free to visit our website and follow our LinkedIn page as well. So let's start with our topic. Cybersecurity is a big data use case. Now, when we say that, we need to know the context behind this. Cybersecurity is a very big domain. It's not a one function. It has lots of functions embedded into it. So when we are saying that cybersecurity is a big data use case, which part of the cybersecurity, which function of the big data security is related to big data and is a big data use case? First of all, let me give you the context behind the cybersecurity functions. The cybersecurity functions have been categorized by lots of standards into multiple categories. The ones that I like most is provided by NIST. NIST is the National Industry Standards and Technology. They have classified the functions of the cybersecurity into 5 areas. One of them is protect. Other one is identify. Number 3, detect. Number 4, response. Number 5 is recover. So those are the 5 functions in the cybersecurity domain. For simplification, I always refer to it as protect, identify and detect, response and recover. Now, what does these 3 mean? Let me give you an example by using physical security as an example. In your house, you definitely have a lock at your door. This is what you do in order to protect your house. Now, if you are obsessed about security and you want to add a level up to your security, you start installing cameras. This is how you identify and detect if something malicious has happened in your home. If you want to connect your cameras with an alarm system, that when a motion is detected, an alarm system, when it's switched off, is calling the police, and then the police will come to your home. This is where you address the response. When you look at the insurance policies and all the other things that you have in order to recover from a malicious activity or intruder in your home. This is where we talk about recover. If you are testing those controls every 6 months, every year, this is where you are doing an assessment. This is in the world of the physical security. In the world of cybersecurity, it's exactly the same. If you are in your network installing a firewall, installing an endpoint protection, email gateway, a proxy, these are all mechanisms that you are doing in order to protect your environment. So that's the protect side of things. Now, once you start collecting logs from all those systems, correlating them, performing an analysis, this is where you identify threats and detect them. If you are triggering whenever there's an alert or a malicious activity is happening, if you are controlling your firewall to block an IP address, or you are controlling an email gateway to drop a file, etc., this is where you talk about a response. When you talk about recover, this is where you have an incident response and then forensic analysis. These are the terms that you hear for the incident response and recovery. Assessment, this is where you hear organizations talk about that we want to assess our controls. Now, our security controls in order to find out if we are compliant with certain standards. Things like the Australian ISM, the PCI, which is for the credit cards, the NIST, and others, those standards, SOC 2, CIS, these are standards. Organizations are performing assessment in order to identify if their security controls against the protect, against the identify and detect, against the response and recover are meeting that standard. So cybersecurity is a very big domain. This is a glance. I spent like what 1-2 minutes talking about the cybersecurity. It's a very big domain. We as big data engineers can help a lot into the area of identifying and detecting. Why? This is because in order to identify cyber threats and detect them, yes, there are tools implemented in the network. For example, intrusion detection system. For example, the endpoint detection and response. For example, SIEM solutions. And I will be talking a little bit about this shortly. All of these solutions are actually doing data analysis in order to identify malicious activities. So identifying and detection in the cybersecurity domain is a big data use case. And why it's a big data use case? Think about in the world of the cybersecurity, we always need to detect cyber threats in real-time fashion. This is where we need the velocity. This is where we are receiving data in real time from all those sensors that we have, or data sources, we'll call them for now. We are receiving data from all those data sources in real time, and we are analyzing them in real time in order to detect threats in real time. That's why the velocity is there. The variety, as I mentioned, we are collecting data from multiple data systems, and also we are doing correlations between those systems in order to identify if a cybersecurity threat has happened. This is where the variety comes into picture. And of course, the volume. Think about it, the number of transactions per second that's happening in your networks, and you're receiving all this data. The volume is very high. So due to the high volume, the need to analyze the data in real time, and the variety of data sources, the cybersecurity identify and detect is qualified to be a big data use case. So the next time when someone talks to you about cybersecurity or and says that it's a big data use case, acknowledge that and say, yes, it's in the area of identify and detect. And if you are a big data engineer who is interested into getting into the cybersecurity domain, this is the area that you can focus on. You need to look at the identifications and detections in the cybersecurity, and you will be able to implement your big data expertise into that domain. So how do we do it? The way we do it, as I said, we have multiple data sources, and that we are collecting, where we collect this data, and we need to analyze it in real-time fashion. So the way we do it is that we implement the standard data engineering pipeline. Whenever you talk to anyone about a real-time data analysis, a pipeline in order to perform real-time data analysis, they will always tell you that there's a standard pipeline where you need to get the data you have the data source, you need to get the data, you need to parse the data, process the data, massage the data, normalize the data. We use all those terms all the time. Then you need to enrich the data if there are any contextual information you want to add to the data. Then you analyze the data, and then you produce an insight. Now, instead of alerts in the normal of the in the world of a big data word, we always call it an analysis. Now, in the world of the cybersecurity, it's called alerts. Let's talk about this now in the cybersecurity world. You have lots of data sources. You have lots of firewall. You have an Active Directory. You have, in order to do the identity and access management, you have email gateway. You have all those data sources, all those network elements and network protection tools that provides you with lots of information. What you need to do is you need to implement your data engineering experience in order to collect the data, in order to acquire the data. Once you get the data, you need to parse the data. You need to normalize the data. You need to put the data into a key value pair. You need to prepare the data in a way that you would be able to run analysis on top of it. And we data engineers, we do this all the time. Any data that we receive, we always build a data model, and then we massage this data and transfer it to that data model, and it's ready to be analyzed. Then you do an enrichment. And with enrichment, this is where you add some contextual information. Now, I will add, say for example, you are doing an analysis for Twitter. I'm trying to use examples from the big data world rather than the cybersecurity world. If you are implementing a Twitter analysis, once you parse the Twitter message and identify the user, the keywords, etc., what you can do is that you can add an enrichment. Is this user is in Australia? Is this tweet is coming from someone of the employees, for example, etc. And then you perform analysis on top of that. So with enrichment, what I mean by this is you add contextual information in order to help you analyzing the data. Let's implement it in the cybersecurity domain. How do we do it? Let's say that you have a firewall. And with that firewall, you have a network admin. And that network admin only works from 8 to 5. Normal working hours. He's not on call. He or she are not on call. You collect all the logs from the source, from the firewall. You acquire the logs, and then you parse the logs. You create that this is the host name, this is the date and time, this is the message, that's the error code. You parse the message. You enrich the message with any contextual information. For example, what you can do is, based on the user who has access, you can add, like the user ID, you can add the full name and the job title as well, and the working hours. So you add this to the message, and then you put it into the data store, and then you run analysis. The analysis says, check if someone accessed the firewall, and in his job description, he's working only between 8 to 5, and the time of this event is out of working hours, raise an alert. This is how it works in the cybersecurity. It's very similar to our data analysis. Instead of producing business insights or answer business questions, what we are doing is that we are identifying what are the possible threats, and then we are building analysis on top of them, and I will touch on that a little bit. So in order to run detections in the cybersecurity world, what do? We implement the standard data engineering pipeline. We implement our data engineering expertise in order to collect the data from the source by acquiring them, then parse the data against the data model, then enrich the data, add any more contextual information that's required, and then analyze the data, and the output of this would be alerts. Of course, if we are receiving too many alerts, this is where we either look at the data analysis and modify them, or we look at the data source and tune them. So this is how we do the data engineering, and this is the complete data pipeline. Now let's talk about the design. How do we design those analytics use cases in the cybersecurity domain? In the normal world where we are data engineers who are involved into answering business questions, we normally start, the way we identify and design and develop the data analytics use cases is by, number one, we need to understand your business. We need to understand your business value chain. Number two is that what are your short-term and long-term goals? What are the key business questions that you want to answer? Isn't this what we do all the time in order to answer any question using big data? Understand the short-term, long-term goal, understand the key business questions, and then we define analytics use cases. These are the analytics use cases. Then we perform an initial assessment to the data sources, and then we design the solution. We collect the logs, we put it in a MySQL database, for example, we connect Tableau, we start building analysis and visualizations in Tableau in order to answer those business questions. This is what we do in the big data analytics world. How do we do it in the cybersecurity world? In the cybersecurity, there's exactly very similar process. It's called threat modeling. Threat modeling, it's a process that's used to identify, categorize, analyze, and prioritize the threats. Now, the threats in this world equals the business questions in the analytics world. So we need to identify what threats do we need, what are the possible threats, and then we build analytics in order to identify and detect those threats. The process to do that is called threat modeling. Threat modeling, there are lots of framework and lots of models in order to do threat modeling. One of the ones I personally prefer, again, there are many, and there's a link in this slide showing you the different threat modeling frameworks available. One of the ones that I prefer is called PASTA, and it's the process of attack simulation and threat analysis. So how does it work? The way it works is we identify what's the objectives, what do we want to monitor, what do we want to identify, what's the technical scope, what are the components we want to monitor. Application decomposition, this is where we decompose the components of that technical scope. Then we do a threat analysis, vulnerability and weaknesses analysis. And then we do attack modeling in order to identify what are the possible threats based on threat analysis, based on weakness, based on attack. What would the attacker do? We will identify that, okay, in order to achieve these objectives, that's to monitor our website, for example. This is the technical scope. These are the components, front end, back end, database, caching engine, etc. Decomposing them, identify the threat for each one of the components, identify the vulnerabilities, the weaknesses analysis, identify what are the attacks that possibly can happen to this one, and then risk and impact analysis in order to provide a priority. Based on that, you start developing the use cases. So in a very similar way to answer business questions and identify the data sources and then developing the use cases, in the cybersecurity world, it's the same thing. It's a risk-based process and a threat-based process. By doing this, we would be able to build what is called rule-based detections. What do I mean by this? Because we have identified the threats, the risks, the vulnerabilities, and then we identify the priorities based on the risk profile. What we do is that then we say, if this happens, then if this and or. So it's a rule-based detection. It means that it's based on programming a sequence where we are, whenever a condition is matched, an alert is being raised as a result. However, in the cybersecurity, things doesn't work like that. Or actually things work like that, but actually there are more challenges that we can think of. The cyber threats keep evolving. And actually in a recent study, it has been identified that lots of organizations are worried about something called internal threats. This is where someone legitimate does something malicious. Another thing is zero-day vulnerabilities. Zero-day vulnerabilities is a vulnerability that was found, but there's no patch for it yet. So it's called zero-day vulnerability. Number 3 is that organizations are very much concerned of the targeted malware attacks. Malware is a piece of software that can cause harm or damage or encryption to steal your credentials or encrypt your files or cause a certain damage to your network. Now, with malwares, there are those malwares that are called whale hunting. So they send massive email campaign with lots of malwares trying to find a vulnerable person. And now those malwares normally are detected easily by the antivirus that you have, because it's based on a hash. The hash, this file is not to be malicious, so that's how it's protecting your environment. However, even if a hacker or an advisor wants to target you specifically, they will build a custom malware for you. And this malware, normally, it's hard to be detected by the standard antiviruses. So what I'm trying to say here is that the cyber threats are continuously evolving. They are evolving, and we need to catch up. They are evolving because of more sophisticated attacks, and they are becoming very hard to be detected as standard-based rule, because we don't know what those people would do. So this is where we say that we as big data engineers, we recommend that you implement the machine learning in order to detect those malicious activities, those threats. How do we do that? The same data pipeline, send a copy of your traffic to your machine learning jobs, let the machine learning jobs continuously read them in order to learn and learn what's normal, and then identify what's abnormal and generate an alert for the security analyst to investigate. This is what we can do using the machine learning to identify the abnormal behaviors, the anomaly detections, and identify that Astrid, for example, is an employee who normally accesses between 9 to 5. Suddenly, she's accessing overnight. This is a malicious activity. We raise an alert. Or Astrid normally doesn't access the Salesforce. She is always accessing the, for example, the technical Confluence page. When we see Astrid trying to access the CRM or the Salesforce, it's something malicious. This is where we raise an alert. So it could be by malware, or it could be zero-day vulnerability, or it could be malicious activity, or someone has stolen her credentials. We don't know. But what we know is that this is a malicious activity, and we need to report it. This is where we as big data professionals are implementing our experience using the machine learning into developing advanced analytics capabilities for organizations. So what we are enabling organizations, we are enabling organizations to use the same data in order to answer different questions. We are helping organizations with ingesting the data. No matter how hard it is to collect the data, we as data engineers, we know how to collect the data from those different sources. We know how to prepare this data and ingest it into the data store. We as data engineers, we know how to develop analytics use cases in order to perform alerting. This is the role-based alerting that I talked before. We know how to utilize machine learning for advanced detection capabilities as well. We know how to build a platform and allow the security analysts and other security engineers in order to do security hunting and security investigation as well. So we as data engineers enabling the security team in order to address all those requirements. And we do it right. We as data engineers, because we are coming from a data background, we are implementing the data best practices. And this is why I put here the DAMA Wheel. The DAMA Wheel, for people who doesn't know, DAMA is the Data Management Association, and the DAMA Wheel provides the an illustration for the data management body of knowledge areas. So all of those knowledge areas are there in the data management framework. And we as data engineers, we live this every day. So when we talk to our security folks, we ask them, do you have a standard data model for your security logs in order to allow you to continuously analyze this data? Have you thought of the data lifecycle management? How long do you want to keep the data? Have you thought of the data interoperability? How do you move the data from one system to another and you can still use it? Did you think of your metadata? Did you think of your what quality measures do you want to have your data? So we as data engineers, we utilize our data expertise and our data knowledge into deploying the best solutions into the cybersecurity domain. It's worth mentioning here that we as a Skilledfield, we are a gold sponsor for DAMA. And this demonstrates our commitment to data best practices as well as the community. We use the data management body of knowledge in everything we are doing. So by utilizing our big data expertise to help organizations uplift their security detection and response capabilities, we help organizations stop malware at the host by utilizing not only the standard malware protection techniques, but also the machine learning and the advanced analytics techniques. We help organizations with their threat modeling. We help organizations develop custom detections based on the threat modeling. We help organizations with enriching the data and using more contextual information to provide better analysis for their security events. We help the customers trigger automations with the actionable insights that we generate. We help organizations unleash big data technologies to solve complex cybersecurity problems. Cybersecurity domain is a very interesting domain, and they definitely need more data engineers involved into it. This is one of the quotes I really love to show how important it is for organizations to protect their cybersecurity. And with the cybersecurity, it's to raise the awareness. So it takes 20 years to build a reputation and only a few minutes of cyber incidents to ruin it. So organizations are now becoming more aware that they need to act on those. They need to protect their their networks and their environments from cyber threats. And this is where we as big data engineers, we have a huge opportunity to help them in the area of detection and analysis. Australian government as well, in 2020 cybersecurity strategy, is also working on raising the awareness of the cybersecurity towards a more secure online world for Australians, their businesses, and the essential services upon which we all depend. So there is a huge investment. There is a huge awareness now in the cybersecurity world, and they need our help. We can do it for them, and we can do it right. Thank you all. This is all the slides I wanted to go through. I hope you enjoyed them. I will stop the recording and I'll unmute also for any questions.